Yo, what's going on, everyone? Welcome back. Today we're gonna be doing a new type of video, which is called balancing chemical equations. So you might have, if you don't know how to balance them at all, it's okay. But first of all, when you see this word like balance, like like in an equation, and if you have I'm talking about math. If you have an equation, you have to make sure that LHS, you have to make sure that LHS equals RHS, right? In the same way, in chemistry, you have to make sure the atoms of reactants equals atoms of products. So like if we have I'll give you an example. Like here, the atoms of reactants is equal to the atoms of products. For example, suppose you have something like this: A plus, these are two products, A plus B gives AB. Remember, we don't use equal, use arrow, because that indicates product. So when you have this is known as the reactant sides, which reactants, and this is the product. Okay, so there can be more than one product, but in this case, see, the atoms are equal, right? But we don't have anything, but I'm going to show that in a later reaction. Okay, so now, and if we can reverse this, like if we write AB, this is decomposition, breaks down into A plus B. This is the reactant, always this side, remember, reactant, LHS, and this RHS are the products of the reaction. Okay, because the decomposition is a reaction, right? That's why. Okay, so now let's start balancing one. Okay, let's do a basic one. Here, now suppose you have something like let's say we have Na. I'm looking for example. Na plus O2 gives 2Na 2O. Okay, so Na plus O2 gives 2. I already gave the coefficient. I wasn't supposed to do that. Okay. Na2O. Okay. So if you see here, this is the reactant, and this is the product. So we have to make sure the atoms are equal. Look, check here. Okay, let's divide this. Let's see the atoms on both sides first. Okay. Now this is Na2O. This is sodium oxide. Okay, sodium oxide. Okay, so let's put it here. Alright, now check here. Look, how much atoms of sodium do we have? We have 1. We can write 1, right? Because 1 is a coefficient, I remember. So 1 atom plus, how much is here? 2 atoms. So this is 3. Okay, now check here. How much is it? Sodium 1. No. Sodium 2. Sodium 2. And oxygen 1. It's 3, right? But so isn't it balanced? No, it's not. I'll tell you why. Look here. You have to make sure every element is balanced, okay? It's not that. It's a big confusion. I think it's a confusion, but just don't do that, okay? Look. See here. First of all, let's count the total number of sodium atoms. Here's 1, here's 1, okay? So the Na is equal to the Na on that side. But here, O2 is not O. Okay, is not singular O. Okay, so what we have to do is we have to balance oxygen. Now take a look. How can we do that? What we can do is, okay, let's make, what we want to do is, we wanna try to make the oxygen, at least on one side we want to make the oxygen have 2 atoms by adding a coefficient. Remember, we cannot put an atom on the bottom, we can only put on the top. So like the solution is you have to put 2 here. Why? Because but then we would have to put a 2 here, right? No, sorry, we would have to put a 4 here, because I'll explain why. We would have to put 4. Now I'm gonna put this in a different color so we can differentiate. So the coefficients are 4 Na, and this would be 2. I'll explain why. Because look, this is multiplying to that. Okay, look, when you multiply this, 2 into Na of 2 atoms, 2 into 2 is 4, 4 Na is equal, 2 into O is O, so 2 atoms of oxygen, and here they have O2, and it's 2, so that's why this is balanced, okay? It's balanced now, okay? Hence the equation is balanced. Cool? Okay. Now let's do one more. Let's do some more. Okay. Suppose we have something like this. We have magnesium plus oxygen. When it's heated. Yeah. Don't worry about the heat. It's not important to balance it, but mention it. Gives a magnesium oxide. Okay, same concept. Just look. This is not too difficult. Look, Mg equal. Okay, but look, if you look at the oxygen once again, O2, O not equal. It's not about the total atoms, it's about balancing each element. Okay, because if you do, the atoms on both sides will be equal. Okay, look, like for in this case, what we have to do, we have to make it 2. So why don't we like that? Why don't we put a 2 here? I don't know this place. Why don't we put a 2 GO, okay, but then we would have to put a 2 here to make it balanced, because 2mg, 2O is balanced. If you count it, there's total 2 here, and look, and if you count the total number of atoms, it will be equal. Here we have 2. Here we have 2. Here we have 2. This multiplies. Just think of it as a multiplier, like distribute. 2 plus 2O, which is O2, which is a coefficient. So when we multiply by O, we'll get 2 atoms of oxygen. So yeah, this is equal. Now this equation, okay. Now this equation is also balanced. Okay, so that's how to balance this equation. So yes, this is balanced. Okay, and then now let's do another example. Okay, yeah, so I think I just do the basic equations. Now let's do something a little more trickier. Okay, now suppose I have something like this. Na2O plus H2O gives NaOH. So how would you solve this? Alright, well look here. This is NaOH, sodium hydroxide, and this is Na2O. Okay, so look. So you have to look carefully here, because now, see, just count the atoms. Now here, you have to see, Na, how much we have here? 1. So this is equal, okay? But then, if you see the, no, Na is not equal. Look, this is 2, and this is just 1. So, not equal. Okay. And then, after that, let's check the oxygen. Oxygen. In this case, O and H are combined, so we can't really tell. But I guess you can say, in a way, it is balanced, the oxygen atom, because it's hydroxide. Maybe, I guess so. So we can consider that. Then we have H2. But this is H, so not balanced. But here we have O. Okay. Yeah, we have an O, and we have O. This is equal. But the thing is, this is O, O, with 2 O. This is 1. Okay? So now, let's figure out how to do this. Okay, check. First of all, I think what we need to do, okay, look. We need to make it equal. Look, we have to make, so, suppose we put a 2 here. Suppose we put a 2 here. Okay? I'm gonna put a 2. Okay. I'm gonna put a 2. So look, if you multiply this 2Na, 2H. So 2O, good. What? This is 1 with 2. So it's balanced, and the H. Yeah, 2H. 2 times H is H. So the correct balance would be this. Okay? Understood the explanation? Got it? Got the explanation? Okay. Alright, it's all good. Alright, now let's move on to another tricky one. Okay? Let me see what else we have. Okay. Let's do another difficult one. Alright. Oh yeah. Okay, here's one. So if we have iron, let me get small. I'm not gonna do every single equation because that'll take a while. I'm just gonna do the main ones. Okay, so you understand the concept. So Fe plus O2 gives Fe2O3. Is it that simple? Let's see. Count. 1 atom, 2 atoms. Not equal. 2 atoms, 3 are not equal. Okay. We can find a common answer. 2 to 3, 6. So why don't we make it 6? What I'm saying is this. Like suppose we do something like this. Here. Check this out. If we do, let me put the Fe2O3. Now, if you wanna let's make the oxygen 6 first, okay? How can we do that? Yeah, by adding 2. Because 2 into this will be 4 atoms. But if you multiply by this, it will be 6 atoms. So now what you want to do is, in this side, you would want to add a coefficient of 3. Okay? You would want to add 3 O2 because it'll be 6. So this equal. Okay, but now let's look at the iron. This is 4. This is 1. Just put a 4. Simple. And yeah, this is balanced as well. Okay. Okay. Now let's go. Oh, there's a hard one. Okay. Alright, let's do a hard. Check this out. If we have, hold on. Is there another? Okay, so suppose this is a hard one. Look, if you have copper plus oxygen plus CO2 plus H2O gives what? CO2 into OH2. We have to bring it outside the bracket. Okay. So OH 2 and then after that we have CO3. Whoa. Okay, check this out. CO not equal. O2 and here O3 are not equal. CO2, CO3 not equal. C is equal, but O3 is not equal. H2O. Okay. H2O. Okay, then we have H2O. And then we have OH2. And yeah, but no, this and this are not equal. Okay, let's start. First, I want to see. We have to make this equal. CO2. But we have to make sure it won't affect the other elements, because whatever coefficient we put here, it will multiply to this also. So, now let's try. No, let's put a 2 here. Okay, because then this will be equal this, okay, and O2 and no, actually, yeah, O2 and OH2, O2 equal CO2. Look, 2, 4, 5, 2, 3, 5. Yeah, the oxygen atoms are equal as well. That was my bad. Hydrogen, we have hydrogen 2. Yeah. So this is the only balancing we did. That's all. So like once you get the hang of it, it's gonna be very easy for you guys. So just make sure to keep practicing these kind of equations. Okay. Now, okay, I'm gonna do the only difficult one. Okay, you know what? Yeah, I think those are the like easy equations. Okay? No, let's do one more, but not too easy, okay? But not too easy. We're gonna do some. Okay, here's a trick question. Check this one out. If we have magnesium plus H2O gives MgO plus H2 plus hydrogen gas evolving. But the arrows are important in this case. Just focus on the atoms. So look, Mg equal 1 one atom equal H2, two atoms equal O. So guess what? This equation is already balanced. So you gotta make sure which equations are not balanced and are already balanced. Okay, just make sure to keep track of that. So you gotta count the number of atoms on each side of all elements. Make sure every element is balanced. Okay, because you know the law of conservation of mass. This states that the atoms on both sides of a reaction should be equal. Yeah, I'm sure you studied that. It's just a law. Okay, and now let's see if you have any more. Yeah, so just make sure to count the number of atoms. And what else do we have? Yeah, I think if you know this much, just keep practicing. Okay, here are some. Okay, let's see. One second. Okay. One more. Let's do one more. This will be a combustion reaction. So, if we have CH4, okay, plus O2 gives CO2 plus H2. Now look here. What do you have to do here? Okay, so look. Basically, check the number of atoms. C1, 1. So carbon is balanced. Hydrogen 4, hydrogen 2. Hydrogen atoms are not balanced. Oxygen is balanced. But we have to make sure to balance only a hydrogen, but make sure it doesn't affect the other elements. So we can just simply balance this term right here. We can put a 2H2O. Okay, 2H2O. Okay, but look, the problem is if we do this 2 into 2, 4. Okay, the hydrogen is balanced now. Hydrogen is now balanced. Okay, hydrogen is now balanced. Okay, but the problem is now, the problem is oxygen. Now oxygen is unbalanced. What do you do now? Here, because in here we have 2 atoms of oxygen. 2 plus 2, 4, and here is only 2. Simple. All you have to do is just put a coefficient of 2. Okay, just put a coefficient of 2. Okay, so make sure to do my method. You can do the, like, it's called the trial and error method. I think you have to count the number of atoms on each side. Just write it, take notes. You can write in a professional manner if you're doing it in school, of course, but I'm making a video, but I'm just explaining it so it's easier, right? Okay, so now I think that's all. Now make sure to practice equations, and yeah, I'm gonna end it here. And yeah, and what else? Oh, I think those are the important equations that you should learn to balance. And yeah, let me give you some practice problems. Practice balancing. Make sure to use my method if you can. Now this is for your homework, for you to practice. Okay, so what we have here, oh my god, okay, we have Fe. Let me put 1 here, 1 Fe plus HCl gives FeCl CO2 plus hydrogen gas evolution. Remember, don't worry about the arrows much, unless you have to like name it. But here we're just gonna balance it, okay? Now second one, I'm not gonna give much. Okay. Here, zinc plus H2SO4 gives ZnSO4 plus hydrogen gas. Now you have to check if all the reactions are balanced. If they are balanced, if they are, you don't need to do anything. If they aren't, then balancing is my method. Alright. Now I'll put a third one here. Third one, just 3-1. The next one that you should try is this one. Na plus HCl. Let's make a line. Plus HCl gives NaCl. Okay, this is NaCl, by the way. Okay, NaCl plus H2. Okay, evolution of hydrogen. So this is your homework, and just practice it. Okay, and I'm gonna see you in the next video. Peace out. Peace. Yeah.